Okay, we're going to focus on next domain and range. Now, domain and range are going to be really important throughout the rest of this course, and I think you might remember a little bit from what you did before. We'll recap it. They've given us another function here, okay, and we've rewritten it down here. These are the ones in black, so all the dots we've written. We also have another function, or technically not a function we've written in red, but we are going to find the domain range of that. We'll find the domain range of this one and this one. So we're going to do 4 different domain ranges. Okay. First one we're going to start with are all of our coordinates they've given us. Now domain deals with x values. Okay. So we're talking about all the possible x values in a set, while range deals with y values, all the possible y values in a set. Well, these ones are specific values. Okay. Each of them is one specific coordinate. So what we have are 1, 2, 3, 4, 5 coordinates. Those are the only things. It's not continuous between them like our other ones down here are going to be. So because it's just specifically points, we're just going to put the values in. Now it's easiest if we do organize it in a table of values, right? And that's essentially what domain and range is going to be. So we're going to do the first one in black. I'm going to zoom out just a little. Okay. Our domain, oops, I want it to be in black. Because our first one was in black. Our domain deals with all of the x values. Well, if we quickly look, our x values are 0, 1, 2, 3, and 4. Okay? There's nothing else to it, so it's very simple. Their domain is 1, 2, 3, 4. Very simple. That's for our first one. Okay? The range are our y values. Well, our y values are 0, 1, 2, and 3. Now notice there are 2 1s, right? Yeah. We don't repeat that one. We just write it once, just like in a mapping diagram. So our range is just going to be 0, 1, 2, and
you have to write that in order too.
3. Yeah, we need to write them in order. Okay? So here's our domain and range for the very first 4 dots. The red one, same idea. In this one we have double x values. Okay? So 2 of our x values are duplicates. So that's, again, the domain. Well, our domains are really just -2 and 4. So there's only 2 values, -2 and 4. While our range are the 3 y values, 3, 4, and 5. 3, 4, and 5. So we just don't repeat duplicates. Okay? That's really simple for the dots. It gets more complex when we're doing domain and range for continuous. See, this is continuous. And essentially, between each whole number, there's going to be a million different numbers I could write. And I'm obviously not going to write them all. We could have 1.1, 1.11, 1.111. It's far, far too long. So what we do is we use x as the element of all real numbers. Do you remember this, XER? Yeah. We use that to represent it. So when we talk about the domain for the green one, because it's continuous, we start off with x is element of all real numbers. And then there's restrictions. This line lets us know, so this means such that. Well, technically, left and right, there are no restrictions. This is going to go on forever. So I actually don't have to put a restriction on the domain. It's never going to stop. It's going to go all the way to the right, all the way to the left, as far as imaginable, possible. Okay, so there's our domain. The range, though, that actually has a restriction. So we, again, because it's continuous, we do start it with YER, and then such that, well, what is our restriction? Now in this case, the restriction is, we're going to say it touches right here at -5. Our range, because it's y values, is all values below -5. It's never going to come above -5 because this was essentially its highest point, and then it's going to continue back down this way, right? So the range is that y
is greater than -5.
It won't be greater than -5. Yeah, y is less than, and technically touches it equal to the value of -5. Okay. And then finally, our last one is their circle. Now, in the circle, we actually do have restrictions on our domain. If you look at the circle, and I'm going to move it over a little to make this a bit easier. Let's see if we can't get some whole number values. And maybe I'll expand it a bit so we can get whole numbers here. I want a little smaller. That's good. Okay, so we're just going to kind of round just to make it easier for ourselves, okay? Left and right, the farthest left it goes is the value of 3, and the farthest right it goes is the value of 9. Okay, so what that means is our domain here, because it is continuous, right? We always got to start with our XER if it's continuous. But the restrictions are the lowest value is 3, And x is equal to and greater than 3, but x is also less than and equal to the value of 9. So it's in between those two. Our range, it also has restrictions. Our low point, yeah, exactly. -4 and -10. So what that means for our range is YER such that y is greater than and equal to -10, but less than and equal to -4. Okay? Do you recall that stuff at all?
Yeah.
Yeah, okay, that's going to be important for this stuff too. We still got to know a lot of domain and range for this.